So we're going to be talking about range. So if you're coming from not even programming, if you're just coming from the mathematical aspects, or you did mathematics even in your basic school, you know that a range is the difference between the highest and the lowest number in a list. But here now you got to understand that range represents a sequence of zero, one or many ascending or descending integers. It can come from the highest level or from the lowest level of integer with a common difference called a step. So let me get this down. Let me take this down too. Yeah, so as I'm teaching, I'm also learning. That's one way to learn is by saying what you know and you get to understand what you don't know. So we say a range is a range represents a sequence of zero, one or many ascending or descending integers with a common, so the common difference is known as a step. So it's known as step. And the most common form of creating and matching range is by the first and last. You know, I told you that range is the when we are coming from the mathematical aspect, which is the difference between the first and the last, or you can say find the range between these numbers. So you're going to first of all arrange the number, then you can say, oh, this middle number, I think that's median. But the range, you have to find like a difference between a set of number. So the most common form of creating and matching ranges is by the first and last, or first or last step notation, auto imported from kernel. One in one dot 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 10, so it's true. Five in this thing is true. 10 in, so it's, do you know why it's giving us true? Because actually one exists in this. Five, you know, if you say one dot dot dot, that's 1 to 10, there's always going to be a 5. So let's open a live book and get to see what we're trying to say in action. Sorry, I've installed it. I don't know what's going on with this time. Yeah, so we're just gonna open a new live book. So that's why it's coming out. So in range now, let me just drop the book here. So in range, let's say this list has so how do we use range? Let's see how do we use range. So they said one in, so we can say so we get 2 because 2 is actually in list. So let's try something that is not in list. So we get false because 10 is not in list. So we use the in. So we use in to check a range. So just take it note. In is used to check whether something exists, or can say using when using range in is what is being used. So we use in, if you notice, we say in, so we can say, let's say 45, 40 in list. So we do it like this, and it immediately give us false because 40 is not in list. So the most common form of creating and matching array is by the first dot dot last or first dot dot last step notation, also important for kernel. So in ranges are always inclusive in Elixir. What does it mean by ranges are inclusive in Elixir? So let's get to understand more on this statement. So ranges are always inclusive, meaning that when you define a range, both the starting and ending values are included. So enum to list range. So if you do enum to list range 1 to 5, enum to list range hash, yeah, 1 to 5 include both 1 and 5, not just the numbers in between. So when they say by, that's what they try to say when they say ranges are always inclusive, meaning like you cannot say 1 to 5 and you're going to start from 2. No, 1 is going to be there and 5 is going to be there. So include both 1 and 5. It's not just a number. Ranges are exclusive, then 1 and 5 might only include 1, 2, 3, and 4, but they are always inclusive. So that's what they mean by ranges are always inclusive in Elixir. So in Elixir, let's note that down. So when you're working in range, you always know that in Elixir, ranges are always inclusive. So let's go to now conclude on range and move to string. So when defining a range without a step, the step will be defined based on the first and last position. Okay. So when you are defining a step, when you are defining a step in when you are defining a range without a step, the step will be defined on the first and last position of the range. I don't understand this statement, so let's get to see what it means. If the last is not greater or equal to the first, then it will be an increasing range with a step of 1. Otherwise, it's the decreasing range. So ranges typically have two use cases in Elixir: as a collection or to represent a slice of another data structure. So the use case of range is just two in Elixir. I like two major. So one is as a collection, then the second one is to represent a slice of another data structure. So ranges in Elixir are enumerable and therefore can be used in the enum module. So enum to list, this is what enum to list, and this is when they say ranges as a collection. You see enum to list, it immediately make that enum becomes a list. And this is a range, so it immediately helps you to map out the number. Ranges also have a single element, 1 to 1, so enum to list 1 to ranges are slice, strange dot slice, Elixir 1 to 4. So this is what a range can also do. If you notice in our details, we did a map, we did a list, a sorry, we did a list. Then we tried to say 40 in this. So we are trying to get it and we got a false. So the same way we can do num to list and just pass a range of number of 1 to 20 and immediately it will give you a list of 1 to 20 data. The same way you can use it to slice. So I always advise you to like read the documentation more thoroughly because I'm just giving you a brief explanation and there's a lot more for you to get here while using this rule so that you get to know why you're using it. Here we saw something now, we needed more explanation on it. So let's see what it's going to give us. Yes, that's good. When you define a range in Elixir without specifying a step, Elixir determines the step based on the first and last value. If the start is less than the end, the step is plus 1. So if you say range 1 to 5, num to list 1, 2, 3. So if you say 5 dot 1, it will go backward. So depending on what is the first and what is the last value, that is how Elixir would map out your map out your range. So we have discussed about range, we have seen its use cases, its identification. So this is a summary, the function, examples, and everything. So let's go to stream. That will be after stream, that will be the end of today's video. And when we come into but before I go into IO.a system, in the next video, I'm just going to be doing a lot of examples of different enums and collection using all this over here. Just be giving you different examples or scenarios that all these are being used. So that's what we're going to be doing in our next video. So please stay with us because as we promised, this channel is a beginner friendly at the same time and intermediate or an advanced developer can learn to like remember some things that they have forgotten. So function for creating and composing stream. So stream are composable lazy enumerables. For an introduction of enumerable, see the Enum model. So we can say so we know they are lazy enumerable. That's the first stream. A stream in Elixir is a lazy on-demand enumerable that does not compute values until they are needed. So a stream is like you have to call it. So it's like a boss is so lazy that it just sits there and it's not like it's not like your enum that you just immediately put a list or something. So there's a way you have to like call a stream functionality if you want to use it. So that's why we call them a lazy enumerable. So they are a special kind of enumerable that can be useful for doing lazy composable operation over anything enumerable. So that's what a stream is. It's a special kind of enumerable that can be useful for doing lazy composable operation over anything. A stream in Elixir is lazy, does not compute values and they are needed. Unlike list, none which evaluate value as immediately. Stream process elements only when required, making it memory efficient, especially for large and or infinite data structure. So we use stream for large or infinite data structure. The key advantage is the lazy evaluation. Elements are only computed only when needed. Memory efficiency. ideally for handling large and infinite sequence composable. You can do multiple transformation efficiently. So creating stream in Elixir is using the stream dot circle. So I know I told you you have to like create it. It's not like your enum dot this thing that you just map or anything. So stream dot circle a, then you do enum dot take. Immediately you can start working with your stream. Stream dot literate. So it helps you modernize data because it's memory efficient in the case that whenever you're doing a stream, if you're doing a number with a list, so it creates a new list, then enumerate over that list. But in a stream you don't create a new it doesn't create a new list for you. It does its operation immediately. So that's why it's memory efficient. So enum takes data, but with stream it's very useful. So let's see what the documentation has for us again in reference to stream. So range equals to 1.5 dot map. So enumerable that in the enumerable that elements are doing. So stream are composable. Any enumerable that generates elements one by one is called a stream. So we say stream are composable. Any enumerable that generates element one by one during enumeration is called a stream. So let's take that down. That's a very key point. So that's like a major difference between enum and stream. Once it's once it generates elements one by one during enumeration, we know we are working with a stream. So then we started with a string with a range, then we created a stream. So we did a range, then we said stream dot map range times two. Then we now enum dot map stream. Created a string that is meant to multiply each element in the range by 2. At this point, no computation was done. Only when enum.map is called, we actually enumerate over each element in that range. So it was when we called enum.map that we started enumerating each of those elements in that list. So this is what I mean by when working with large number. So you see, it's very eager. When you start doing it, immediately it starts compiling itself one after the other, taking the first result. But stream is lazy. It doesn't have time to like start running through the distance. It doesn't last. So we talked about creating stream. So functions struck every. So these are what can create a stream. Things you can do with a stream aspect of enumerable. Because a stream is a special kind of enum. So it's still in the enum family, but it's a special kind because it's a lazy enumerable. So please go through the documentation. There's so many examples. So the next time we meet, as we said, we're going to be learning about the different examples from access, date range, enum, keyword list, map set, range, and stream. Thank you for sticking with us. We love having you here. Have a wonderful day. Bye.